What's up, guys, and welcome back to another episode here on the ArchiTech Network. Today we're going to be jumping back into the world of metaverses, or sort of the metaverse. We're going to be talking about NVIDIA's Omniverse, and we're going to be doing that with Cobus Botma. So Cobus spent a number of years at KPF, and about a year ago he transferred over to NVIDIA, where he's working with their Omniverse platform. If you haven't heard the Omniverse before, it's a super interesting platform. I always find it hard to describe it to people because you almost have to simplify what it is. It's hard to get across its true potential, which is really mind-blowing. Omniverse can be described as an industrial metaverse. It's essentially a platform where we can bring in and link in all of our kind of design tools, whether it's Rhino, Grasshopper, Revit, 3ds Max, all of these kind of things. There's now plugins that you can transfer geometry and information directly from your design software into the Omniverse. And in some cases, this is a two-way connection. So if you change something in the Omniverse, it also changes back in your design platform. And once you have it in there, you can view it in a super high rendered. You can view it in augmented reality, virtual reality through the web. But where it gets really interesting is you can tap into the computational power that NVIDIA offer, of course, through all their graphics cards, and run incredible simulations. You can test automation of things. A good example of how this is being used is with the automotive industry. You see car manufacturers building their production line in the Omniverse, and then they test out thousands of different configurations to optimize their production line in a digital world to then go and update the physical world. NVIDIA are also, of course, heavily involved in the AI world. They're the one company that technically all the AI companies are working with, because most of these models are running off their NVIDIA graphics cards. They also have a huge component in the AI side, which we'll also touch on with Cobus. As always, though, if you like this episode, please give us a like and a subscribe and share this with your friends and colleagues. You can follow us on LinkedIn and Instagram, where you can see upcoming courses and events and videos. We will be having a Petricuccia here in London at the end of September on the metaverse and beyond, where we'll touch on all of the stuff that we'll be talking about in this episode. And finally, we're also looking for small, medium, and large companies that are interested in getting beta access to everything that we have on our ArchiTech Network platform, all of our courses, for an annual fee. So if you're interested in that, please reach out to us at hello@architech.network, and we'll see if we can work something out. But without any further ado, let's jump into it and have a chat with Cobus. All right, that's it. Cobus, we're live. Thank you very much for joining us on the podcast.
Thank you very much for the invitation. I've been watching you guys for a while, and this is really, really exciting to be part of this. Really exciting.
Yeah, no, I've been strategically waiting to get you on, because I think it's a perfect kind of time. I've loosely been now trying to do the podcast and also our Petricuccias in these themes. And I'm wondering if we should do like seasons kind of thing. We just had the AI one. We've had a few people on talking about AI, and we're also the next Petricuccias on the metaverse, game engines, immersive worlds, and what you do at NVIDIA kind of sit in between those two worlds. So I thought it was a good time, and hopefully we'll also have you on the next Petricuccia to talk a little bit more about what you're doing. But hopefully we'll cover most of it today.
Yeah, absolutely. I hope so. Well, thank you again. I really appreciate it, and I appreciate the time you make for this as well. It's a really good network.
Awesome. So a tiny little further introduction to the one I've just given on the introduction is just so people have a little bit more information. So you're an architect, and I know you studied product design and things like that, but you've basically spent the last 15 years at KPF, right, working in the firm KPF, which is a huge firm. And you worked there for a number of years. And I think your last position was you were kind of director of applied research. And you're kind of doing it a little bit, what I guess we call a big, like the design technology side. You're doing like computation as well as the visualization side. So it's like a bit of everything, right? And now you've moved to NVIDIA a few years ago, and we'll talk a little bit about what that is.
Well, only 1 year ago.
Was it only 1 year ago?
It's only 1 year. I had my anniversary the other day, so it's actually
Really?
it's one of those things. If you are very busy, it sounds like you've been there for 10 years almost already. But yeah, I mean, you're 100% right. I studied industrial design and I practice industrial design. And even at KPF, I did levels of industrial design. I have no training in architecture. I grew up in architecture. But probably about 30 years ago, I got involved in architecture from a software point of view, and then we were running the pre-BIM softwares and building BIM models from sketches in the sort of late 90s, early 2000s, and really output of it was qualifying what was designed and visualizing what was designed those days. And then, as I said, in 2008, right before the big economic crash, I joined KPF as designer and worked for 6 years intensely on a really large project, which is going to be featured in a movie very soon, which is very cool.
Oh, very cool.
Yeah, Mission Impossible. So if you see Mission Impossible, you'll see our project in there, which is pretty neat.
Cool. And
then I moved from design because I think my history in design has always been to, and this is part because of the industrial design, product design training. You don't always know who your brief is and your client's going to be. It's not quite like architecture. You walk into a new area. I mean, I met surgeons that needed to design oropharyngeal dummies for babies at the same time as doing an advanced toilet seat. Right? They're two different worlds, right? And you have to learn very quickly and adopt and be able to make decisions right there based on what you know is possible in the future. And I think that's kind of the way I looked at architecture as well. So I've always pushed technology, and that's how I ended up being director of applied research. And it was very much looking at strategic at the next 2 to 5 years of where the practice would be and what we need to do to be ready for what's coming our way. And that's how I kind of got involved with NVIDIA. We were doing some acceleration, compute visualization, as well as AI with GPUs, testing some of the early stuff. And I was one of the first sort of pre-alpha architectural testers of Omniverse. It was you got to a point. I got to a point where I started getting anxious about the industry, really anxious about the industry and in general, design in general. And I knew that as much as I loved KPF and it was an amazing position, I couldn't help the industry from inside of practice as much as I could stepping out of it. So so we're a team now of six architects in a huge company. We run almost as sub companies within the company, and we're seeing where we can push and help the industry moving forward, basically. So it's a very very responsible job.
Yeah, I mean, we'll definitely have to unpack some of that concerns, because I think we've had a number of podcasts where I'm sure we'll touch on maybe some of those concerns. But it's something I probably share a little bit as well. That's partly why I started ATN, is to have some of these conversations, right? So you joined NVIDIA about a year ago, and I know you've mostly been working with NVIDIA's Omniverse, right? And maybe I'll get you to do a little elevator pitch of that. But you said you've got a team of 6 architects. So I think what's interesting, a lot of people will not know that. Will be like, why do people think of NVIDIA? They think graphics cards, right?
Absolutely.
And that's what they've been doing for the last few years. But of course, there's so much more than that. And they're involved in, as I said, this AI world, this immersive game engine worlds, whatever word you want to call it, both in the hardware and the software. And I think that's what's super exciting. But it sounded like you joined specifically or initially for Omniverse. So maybe give the audience like an elevator pitch. What is Omniverse and why are architects involved in it?
Absolutely. So you're 100% right. I mean, NVIDIA at its core is a hardware company. Right? The big things that happened is we kind of invented RTX, ray tracing cores, and with that, and this is a prelude to where I'm going to it. The GPU was built to do ray tracing, but also had tensor cores so it could do AI, because the function between ray tracing and AI is very important in real-time upscaling of images. So you render an image smaller, and you don't realize that as a user, and in the backend it upscales it, through super sampling and the likes in real time. So this is where the ability to do thousands of parallel processors versus a CPU became so important in the world of machine learning and AI.
Right.
So that is the back end. So we very much, it's very much a hardware company. And if you follow some of the latest trends in terms of the new hardware being developed specifically for these functions. But Omniverse is really, and this is quite an important topic, and I think it's a huge misconception out in the world. It's not a software. And NVIDIA don't do software. I mean, we don't sell to clients. None of the stuff we sell are to clients. We provide back-end systems for software developers and hardware developers and providers, the big cloud providers and so forth. So we provide them hardware, but of course, with that, we need to provide them frameworks and platforms and SDKs and so forth to support that hardware, to break it down into points. So if you open, Unreal, they run some of the super sampling that we do. If you open a Rhino or Unity or Max or any of these tools, all these things are semi-supported, V-Rays and so forth, but at quite big levels. So Omniverse was really a jump from a previous application called Holodeck that I was working on a few years ago, which was a collaborative VR application across continents as such. And I think the reason why Omniverse was developed is that NVIDIA saw that there are so many SDKs and platforms that can run independently, AI frameworks and accelerators and the likes. But they wanted to create a place where people can apply all these things in one space. So they created this platform, and it is quite a base platform, but it's built with little extensions to make it work the way you want to work. And the most challenging thing I'm trying to get across about Omniverse is that it is a platform that is not locked down or bound by anything. So if you want to do whatever you want to in it, and this is a big thing, you can go and write a bit of Python script and do that. You want to employ GPT into it, or you want to employ diffusion, or you want to run a recommender systems from NVIDIA in it, or whatever the case is, you can go and do that. Now, it is a visual front end. It's very important that it's a visual front end. So we run ray trace as a start. That's the lowest quality we go. And the important thing that happened with that is we needed a schema to work in Omniverse. So and the schema we adopted was USD. It's been open sourced in 2016, and it is developed by Pixar for problems that probably 12, 15 years ago, problems they had that we don't even have in our industry yet, right? A really hardcore collaboration problems that is not export or translate and retranslate. It's really you and me in different continents working like we work on Miro, like in real time, but in 3D scenes. So USD was adopted and forked and developed, and now, of course, we have OpenUSD and the alliances of OpenUSD, and it is really a schema moving forward, and that's the basis, that's the core of Omniverse. So you have this platform that consumes USD from anything that you can go and compute anything on top, geometric, visual, data, AI, simulations, robotics, whatever you want to do, and it's agnostic, right? USD is agnostic, which is cool. So it doesn't care about the data where it comes from. So I think when you first showed it to us, I think it's like I could totally see that it's hard to describe to other people what it is, because you almost have to dumb it down. Like, well, it's kind of like a game engine, or it's like a metaverse, and that's why I can never quite describe it in one word. It's neither and all, right? So that's the thing. So I mean, the big thing is we have clients that are super good, that are using this as a working model. And then they take it to game engines, because it's not a game engine. We can't do what the game engines do. And I think the biggest thing about this underlying is that it's and this is a thing that's going to be affecting us more and more in the future, is that it's built on a complete open agnostic schema. So and this brings the question that I think you're probably anxious about, and I've been anxious about, is the conformity to softwares. And we have to use a software to do a tasks, and it's not the best software, and it's not the software we should be using, but it's the only software we know that can collaborate with our other software, right? So now you can go and use whatever you want, literally whatever you want, and be in the same place with the same data sharing schema, So
I think that's what's really exciting about it. I mean, there's two things I'm really been excited about this year that I'm personally trying to develop my skill set in is all the kind of AI stuff, taking keeping up to speed with that, but also the Unreal 5 world, game engine world. I really think that's going to be a big part of the future. And combined with something like Omniverse, I can just see how powerful it can be combined with something like that, where you can, bring all these tools together in one space. So like in an architect's layman terms, it's a virtual space. You can bring it. You have plugins for Rhino, Grasshopper, Revit, all this kind of stuff, and you can bring all these things in. Some of them in real time go back and forth, right? Which is super interesting. And then in that space, you can really do anything. Like once you got it in there, it could be something you overlay on site. It's something that could be interacted with via the web. This is where it gets hard to kind of describe the endless things you could do with it. But for example, you've got companies like car manufacturers, right, making their production line virtually, testing it to dictate how they actually physically run it or build it. You could, in theory, also do like train, I don't know, AI models on the roads or something like that. It's this a virtual space. You can do all this amazing stuff with it. What do you see architects using it now for? And there's endless potential, but what are they kind of using it for most now at the moment? The kind of things, I guess, that you can discuss.
Absolutely. I mean, so architecture is very visual, as you understand it as well. And the other issue that they have is collaboration. So we do, for example, analysis models, and we have models from a company that does some form of terrain, or a company does some form of structure, and then somebody does some form of 4D scheduling, and you can take snippets of that and force it into a software where you can view some of that. Right, and now you're running on a cloud-based, say, CFD solution, and now you have to deconstruct the data coming in and give a diagram that is sitting next to a visual model of what it actually is. Right, and there's no way to combine these, and this is where USD comes into play, because all these through connectors, and some we develop, and some the software industry is developing, and they're really adopting it. They can write it into USDs. Now, USD is very interesting in how you can collate and build models with multi-USDs. There's systems like layering, so it's almost like photoshopping in a way. There's ways of running payloads, so you can run really large models, and it's really efficient in how it works. So all of a sudden, as an architect, you can actually open up a model and have somebody with Grasshopper live linked to a highly visual model that has cloud-based CFD compute, Revit, and maybe ArchiCAD models, some more Rhino models, some SketchUp interiors, whatever it is combined into one. And the beauty about it is every sub-discipline of that is owned by the sub-users, and they use their preferred applications. But you as a viewer see it all together and go, well, can you jump that slider quickly, because we're looking at square columns here and we want to move the facade away a little bit, or whatever the case might be, right? And you're not seeing it in a diagram or a isolated. You're seeing it as what I refer to as an experience model, a simulation model, right? And you can go and hit play and actually see a wind move around the building and see what the effect of trees of that wind would be, and the likes. So it is very much, when you talk about metaverse, we refer to this as industrial metaverse, the actual working metaverse, to create a virtual twin to get it right before we build it. And for that, you need everything in one space, and in a way where it's not imported and exported. Because you speak to some of our clients, they go, well, what is the biggest pain? Well, we get the models, we take 2-3 days importing, exporting. By that time, the models have changed, right? Yeah, it's changed, right? So you want this real time link, and bidirectionally we're going to see coming more and more often. So already now I can run a Grasshopper slider and move it, and I can see a model update in Unreal Engine live from my slider, because we're running via USD back down into Unreal Engine. Right? Or I can have someone move a tree in Maya that is moving the tree in Max. So the tree in Maya moves because the tree in Max moves, or the Revit column moves, and therefore the Maya column moves, because there's bidirectionality in some of these. And that just becomes a non-data aggregator, or a non-collaborative aggregator. It becomes a single space, a single ground truth. space,
Yeah.
at scale. And this is important, at scale. I mean, with cesium these days, we can look at the whole of London and zoom into a screw into the building if we want to. It's doable. It's cool. It's mad.
Yeah.
I wish I had this 2 years ago.
Yeah, I think it's like on one hand, I can like the low hanging fruit is it's kind of like an amazing place to bring all this stuff to like federate your model, and then you can run analysis and all this kind of stuff. So it's almost like an internal. I don't know. CD is a bit of a reductive term, but
a scale up of that.
Yeah, and then you can do all this stuff, and then I feel like the next stage is this thing could become a digital twin, where it's like, again, to use another buzzword, but like it could actually be a digital twin of things and connected to the real world. But then on a much broader idea, like you in theory could build cities and test cities and run them in this virtual world, and the cars go around. You say, "Oh, there's a massive traffic jam because we put in this gridded system."
Yeah, absolutely.
And that could go and you could build something and test it before you actually build it, and that's what I think is potentially super interesting. Is like this iterative process,
and because it's agnostic as well, and completely agnostic, and people don't get that. It's not developed for ASC, it's not developed for car manufacturing, it's not developed for Pixar movies. All of a sudden, our ASC industry, that's pretty much locked by defined softwares, right? Is open to any other level of compute outside of that. Any other level of compute that anybody else is doing in any other industry. So whether it's something they're doing in Houdini based on visual effects, or whether it's something they're doing in industrial automation for robotic assemblies and line assemblies, using stuff like Flexum or visual components or stuff like that for production line assemblies, from automotive down to semiconductor scale, you can apply some of those things into the architecture game now for free, because you're running an. If you look at it in a way like, and it's a kind of comparative, but it's not quite at HTML. If you open an HTML page these days, right, you have a graphic designer that knows nothing about e-commerce or authentication or databases. You have a data engineer that does only the databases. You have so many people playing together, but when you open the browser, you see it all together, and you don't understand all about backends because you don't need to. You're concerned about the content being delivered, right? And you make decisions based on the content delivered, and that's kind of how you see it. So you're going to have an AI engineer doing backend functions on a model that you are busy designing in Revit, and help you inform that, because you're in an agnostic space. This is the beauty about it. So, and it's powerful. It's an important thing for our industry, because that's one of my fears, is that we are locking ourselves and trying to develop inside of ourselves and solving problems inside of ourselves when others have solutions.
There's a lot of silos, right? Of information.
Others have solutions. Yeah, absolutely.
And that's where it's a solution to that. It's also a problem in the industry. Like architects are working in their little bubble, and engineers are working in their bubble.
Yeah.
And then contractors, they're on another planet.
Exactly.
And I almost wonder if they are kind of would be your first case scenario kind of thing, because that's perfect for them. They can gather all these things from all these different people and see it in one place, overlay it in the real world,
absolutely,
or grab information from it, or whatever millions of things they can do with it,
and apply computer vision and all these kind of cool things that they can do on site. So a single camera can actually capture and generate 3D models of what's actually happening on site, because they're applying that on top of a Revit model, which you can't do in Revit, right? So Revit's great for what it does. So, but the point about the contractors is actually very, very true, and we've seen this with other adoptions in architecture as well, because contractors it's quite a black and white business, right? We have 18 months to deliver this on this budget. There is no fluffiness, right? There is no give. It's a clear Gantt chart that needs to be ticked. Right, not like architecture that it flexes the whole time, right? And we know when deadlines are, and we have to hit deadlines. But we're doing 90% of what we could. We can never do 100. We're a contractor. The concrete needs to get cast because the trucks are standing outside. Right? There's no give. So, and these margins are important, very, very important.
Yeah. So, and it's every time I speak to you, I'm kind of like, you just mentioned the cameras are there scanning, they're like scanning the building, and that can go into this environment, and then it pipes over. It's almost like, hopefully it will connect the dispersed industry, and I can see the advantage for contractors and all those kind of people. But then I think maybe it would help bring together, different disciplines, and where it could be extremely powerful is that situation where you've got the design and builder as one thing.
Yeah.
And like the design team at this end, and then it's going onto site, and you've even got like digital fabrication mixed in there.
Yeah.
That to me seems like
so here's
the dream case.
Here's an awesome case. You've done buildings. You do facades in Revit, and they're great, but the facades need to be done for documentation, and they are specified and so forth. Right. Do the fabricator use those facade models? No, they don't, because the fabrication model is done in different software at complete different skills and levels and so forth, right? Yeah. But why can't you combine the two, right? And this is the question. And you can, because you can take your Revit model and connect it, and in the connection, you swap out your simplified facade panel in Revit, or your documentation level, I wouldn't say for simplified, but your documentation level facade panel with the engineering model. So when you open it in a USD, like Omniverse, you see the engineering model in place of your Revit model, and you can actually understand to the point of where seals are, connectors, hinges, handles, because that's the model that will be fabricated and put in place. Right? So this gives you power as an architect, because all of a sudden the fabricator is feeding you, and you just specifying where their model needs to be placed in your space. So,
and in theory, let's say the way they're doing that, I'm thinking like from the world I used to be in at Front, is that input, which is your Revit model, which is like a panel as a block, essentially, a bounding box.
Yeah.
And then that's your input for some kind of script. That could actually be running in Omniverse, right? And
absolutely.
Like this thing is basically just happening as you update it, right?
Yeah. I mean, you open the Omniverse model and you scale, or you do a different layout, and if it's connected correctly, it will just exchange that facade panel with the engineering panel, the fabrication panel as such. And we do this a lot. I mean, we've done this quite a bit. I think I've showed this in some of the talks. I do some Grasshopper scripts to optimize the placement of blocks. You've seen that. But the blocks are replaced by full detail models done on a completely different piece of software. So when I move something, I see the full detail model move, because I don't need, this is the big thing, I don't need all the detail running in my computational script. I need to do in the computational script what is important for that function, right? And we're talking about functions here. The interior designer needs to do what they need to do as a function, but we want to combine functions and make up the complete building here, the complete project at scale, from a house to a city, as you said. So, and that's cool.
It's like this is every time I speak to you, my mind's like boggling. But at the same time, I'm kind of, when I try and explain it, I have to almost dumb it down to kind of get the conversation going, because it's
well, it's because, Ollie, we are fixed in our ways, right? We're very fixed in our ways, and this is why people look back and they try and solve what we've done in the past. And I don't want to jump the gun here, but a very important thing is that it's not where the future is going, and that is one of my fears. We need to keep the knowledge that we have from the past, but we need to ignore how we've done things. Now, it's a very, very difficult thing, because that in practice, you can't just tell people, okay, we are shutting down now, and tomorrow we start with a new system. It doesn't work like that. It is a very, it's like the horse to the car, right? Now we're going to have a horse that can run 60 miles an hour. Right, so let's start there. Now we got a horse 60 miles an hour with a steering wheel, right? And now we start adding the pedals. You can't just say, okay, you don't have the horse anymore today. You have a car tomorrow, or everybody's going to crash, right? I don't know where they're going to go. So it's like, so we're at that point now, that pivot point, and it's as I say, is if we solve issues within our industry, just make sure we can play with the rest of the world, because the rest of the world is going to interfere, going to affect our industry. So
And, and as we're talking about all this kind of stuff, the AI side of things is exploding, right? And
well, this is the point.
And you guys are obviously quite involved in that as well, right? And I think there's already been glimpses of, some cool things I've seen from examples where you can type things in and it creates like a 3D model in programs. But maybe touch on like what's NVIDIA's role in all this AI stuff? Because you're kind of
yeah.
a key
So we run
player.
the back end of many of these systems. I can tell you that.
Yeah.
The hardware, and it is super serious hardware that is used to train many of the models that we are using and assuming, and this is an important word today, is trained on our hardware. And optimized on our hardware and so forth. Not necessarily on all our frameworks, but I mean, to give you an idea, NVIDIA has over 300 frameworks, right? So, there's things like Nemo and recommender systems. We have modulus, which is upscalers of CFD. We have Isaac Sim, which is robotic simulations. And so all these things are SDKs, as I said earlier, developed to help, to be adopted by others to help them train. But to put it in our CEO's word, we're probably the only AI company working with all the AI companies. We really do find the back end to accelerate and scale economically. Maybe not always financially, but in terms of power consumption. Every time we bring out a new card, it runs less power at double the speed. It's kind of insane what the engineers are doing. But we very much driving this, and it's a very important thing. I mean, I mentioned the assumption in my previous sentence. I've been speaking to quite a few, and I think this is the point we're getting to now in the industry as well with AI adoption. I've presented, I think the first time I kind of mentioned this was like in 2018 or something, where we talk about human interface to compute, and then the compute experience, right? And there's three distinct bubbles. And when we talk about human interface with compute, and this is sort of 2018, 2019, and it was a difficult thing for me to even understand. We don't want you to be a creative, good architect 40% of the time or 30% of the time, and the rest a software technician, right? Because software is hard to work with.
Yeah.
Now, that software technician part of it, which has been existing for the last 20, 30 years, it's going away, right? And I think that's a difficult thing that people don't want to release, number one, because they are good at what they do because they know the software very well, right? And it's taken them a year or two to master software, to be able to design, right?
Yep.
That's being democratized. The coding language of the future is English or Chinese or Spanish, however you want to talk about it, And the input, and this is important, the input to compute will be your preferred method. If you want to sketch, talk, type, mouse, however you want to do. Compute is going to move away, and then you're going to get an experience back. So when you sketch, you're going to have an experience in real time coming to you to make you understand and judge the input of your sketches. The rest is ambient, right?
Yeah.
So
and there's no better example right now than all this mid-journey image generation stuff, right? I was actually doing a fun little competition with our marketing guy Sammy, who's an aspiring architect, and I was like, oh well, let's get you on Midjourney and we can start iterating. It was a little mini competition for creating AI images, and I just thought afterwards, I'm just like trying to explain to him like how much I would have to teach you to create an image like this. I would have to teach you to model, to render, develop a sensibility, which I guess you still have to do. Photoshop, all this kind of stuff. And he types in what he wants, and this is all done in a matter of seconds now.
And being from marketing, he was probably pretty good at it, right? So
yeah.
But exactly. You see, this is the thing that's gonna this is the thing that's gonna happen, and this is one of my other. I mean, I'm not fearful. I'm very optimistic, by the way, just so you know. But one of my things is because it's becoming and I don't like the word democratized, but a way of easy generation. There's two things that need to happen as designers or whoever it is that's operating this. It's first of all, and then this is going to be the challenge, and it's probably a way bigger challenge than I make it out to be, is that architects are going to have to learn to be architects again. And I know that I say this very sensitively, but the designers are going to have to learn their subject matter and be amazing as humans at design again. Listen, understand, think laterally, do the 180 turns that computers may not do, all these kind of things, and understand how to verbalize that. Right? So they're going to have to focus on design, because all of a sudden they don't spend 2 hours a day designing and 6 implementing. They're spending 6 hours designing, 2 implementing. Right?
Yeah.
And the second thing, it's going to make them have to trust and judge what comes out, That's a very important thing. Understand that what comes out isn't going to be the, oh, wow, this is cool, right? Is this what we really need to do? And how do I affect it so that I actually get the output that I want, that I think is best for the client and for the project? So, and it's about the applied side of AI, which is starting to creep in slowly but surely. The wow is getting softer now.
So your argument would be, in fair, it's not, which is kind of maybe a bit my perspective is, it's not necessarily that this AI stuff would take over. It's more that we will truly be collaborating with AI, and hopefully in the good scenario, we're automating the stuff that we don't really need to spend time doing, so that we can spend more time where we actually add the value, which is designing, critical thinking, what's it like to feel being in the space, blah, blah, blah.
Absolutely.
So
and understanding our clients, understanding humans, right? I mean, it's a human thing that we're going to get back to, which we, we're looking at the coolness of it now, but it's humans that inhabit these spaces. I mean, I remember my dad passed away many years back, but I mean, he was an architect, and I remember as a little kid being in his office, and he was great at what he did. I mean, he could draw facade details, understand briefs, everything, and so forth. He could do technical drawings. Those are the days before computers. So you can see my man. But he had what was referred to as architectural technicians that he would then instruct, and they would go and do all the drawings, and he would come back and mark it up with pencil and give it. Those are now computers. So his focus, the designer's focus, her focus would be client interaction, understanding, and coming up with the brief for production. And I mean, we're seeing great things like this moving in now. So, we just released some of the things, text to material, for example. So you're sitting with a building and you're going, I mean, I wish I had a stone like that. Let me go browse the internet and go find. No, you don't have to say, create me a stone that is this and this pattern in a Roman tile pattern. And oh, no, I don't like this one. Okay, that one, apply that one. Right. So you are actually just instructing, and you could speak to the computer even doing that. Make the wall a slightly darker brown. And the computer will make your physical 3D model materials update. Arrange the chairs in a different way. Make it more a casual bar scene instead of a formal restaurant scene. It's not stuff that you have to go and do.
Iterate a lot quicker. I'm already
it's like
thinking
brainstorming
now,
with a computer, and it just does it for you. So,
Again, like a super dumb example is even with the Photoshop AI, I'm having flashbacks of how many hours I've spent looking for a guy standing up holding a coffee with the sunlight to
and that background isn't quite nice. I wish it was a bit more hilly and green. Now I've got to go find an image, cut it out, and well, exactly to that point. But I mean, we do this with 3D models already. Make the interior look like you can make the interior look like a 30s bar or something, or make this look like a modern wooden facade interior office, right? And you can talk to it or instruct it by text or however you want to do that. So
so that's the kind of more positive outlook of how it's going to. What are your concerns with how it might reshape architecture practice or affects architects?
I mean, the biggest thing. I think the biggest thing is still that it's the fact that people change management is a big thing. People don't want to release. And we're talking. We speak. We understand and we see and we get future tech and we get AI. But for many, it's don't move my cheese, as if you refer to the book. Don't adjust what I'm doing right now because I've done it like this for many years. And it's probably going to take software companies and the likes to actually go and say, well, we are not giving you the tools anymore that you have. There's still people that run AutoCAD, and there's nothing wrong with that as main design tools, right? And we're in a different world at the moment. So my fear is really the kind of adoption of applied AI, like a proper applied AI, but more so the new platforms that will come out and be presented to you. It may not be a desktop app. You may be logging into a browser to do something. And this is the greatness about, again, starting at the beginning of what USD offers, is that now all of a sudden you can go to a browser and deal with a company, say, in New Zealand, that is really good at what they do. Maybe it's in terms of heat and gain of facade elements. That's all they do. Right? And you can go to the website and do a function and get it back into your main model. And you can go deal with another company that does vegetation and, go and deal with that and bring it back into your model. So it's not one system that needs to do it anymore. And I think the adoption is a big thing. But the second thing is really getting back to the fact of what happens if technology or design becomes a democratized platform, right?
Right.
That's a hard one to swallow. And this gets back to the point of you have to be really good at what you do as a designer, right? Because that's going to differentiate you. It's not your tools anymore, because the tools are available to everyone, right? So focus on what you do, and that becomes a human relation thing. Ollie, that's all it has. It deals with human relations and understanding humans and being able to understand the site when you stand on it and get a feel of it and create a brief.
I think I mean, you can see that a little bit now with the image generation side, right? Anyone now can create cool ideas. But right now the technology is somewhat limited to 2D images, right? And we're seeing 3D and stuff like that. Eventually there'll be AI that could, produce a BIM model and, shit out drawings so you can build it and all this kind of stuff. But like I said, I think the magic of it is the story behind it, the thinking behind it.
Yeah.
And that's why I do wonder, like, more process-driven architects, where there's a story behind why something is that form, the building is performing in a certain way. I think they can be really powerful. If you're more of a style-based architect, should you be sweating a bit more, because style can be very easily replicated? Does it make you more valuable, or does it because you're the authenticator of that style, or does it make you less valuable because now anyone can type in your style building and replicate it?
You're 100% right there. You're 100% right. And it is a point of, again, the emotion side of it. I don't want to call emotion out as such, but I remember years back before we started a project, I used to get whoever was in the project to go on site and actually walk the site. You get a feel and an experience. You hear noises, you smell stuff. It becomes sensory, right? And you start understanding and speaking to the client. You hang out with the client in the bar afterwards, understand what their needs are, what they're asking for. You speak to the estate agent; they've got different needs, and then this is where the magic comes in with humans. We start collating and making this picture and the story, exactly what you're saying there, of what we should deliver that will give a unique experience for the inhabitants of that building, the users of that building, and how it will affect the neighboring buildings. How we get there, that's the part that's the easier. The what is the difficult one, and that again, I get back to the point of we need to be human thinking people. We're going to have to know our subject matter, and our subject matter is not just design; it's humans as well.
And the way that I just posted something this week about how I see architecture practice changing, which I feel like the way that this would affect an architecture practice is you would see much smaller firms with more tech savvy, in that they're either mentally more open to using this kind of stuff, or they do have that background in the techie side now of BIM computation, all this kind of stuff, and they would be able, much smaller firms would be able to compete with much bigger firms, and so therefore we might see a bit more of an interesting, diverse market in architects, like more individual firms with individual outlooks, and less massive firms. I mean, you could see it, the big firms get even bigger. But,
I mean, it is. It's at the moment, it is a game of agility. How quick you can move, how quick you can run around. It's not a new thing, though. I mean, I've seen this in the 90s. I've seen this in the 2000s of companies that adopt certain methodologies, and a 5-person practice can outperform in terms of profit and projects 30-40-person practice. Because they are skillful at what they do, and the one thing you said is they have the attitude or the aptitude to adopt these tools.
But do you think there's something right now that, like, yes, if a firm, BIM for example, it's nothing new, it's been around for 20 years at this point, and we're still having conversations about firms adopting BIM. But BIM, like all of this AI and immersive worlds is moving so fast. Like the BIM train is slow. It's a snail walking along the track. The AI train is a bullet train that's
No,
that's coming
it's a
by.
rocket. Yeah, no, it's a rocket.
Yeah,
yeah. No, absolutely.
I think that's one of the concerns for me is just like, we're still having conversations with firms to adopt BIM, around the world. This AI thing,
So
before you blink, it's game changing.
So here's the big thing I think is something to consider. I'm from the belief, and I'm not alone, and I mean, others are saying this as well, that the world of computer as we know it, right, is about to change. I use the horse in the car kind of thing. It's probably even bigger than that. The way we use BIM is still a way that computer technology in design has developed, and it's just an iteration and a formation of the technology adopting. Oh, now we're adding some data and we're making it parametric, and you can extract stuff, etc., etc., etc. Right? As you said, it's not a new thing. I mean, I think the first application that was similar to that I opened was in '96. It was Brickworks, adopted by Bentley Systems. But what's happening now is a complete new playing field of compute. And I mentioned ambient compute before as well, because we are consumed by it in many other industries. Well, actually, not even many other industries. We are consumed by it in our own lives without knowing it, right? And social media has gone and taken over a lot of how we exist, and how we operate. AI is going to do that, hopefully more so. Well, it's done it already in personal life. We don't even know about it. We talk about ambient compute. I take my phone and I do stuff. Even if I take a photograph, I'm involved with AI, right? And there's AI models running the taking of the photograph. When it becomes to the industry level, the sort of commercial level, that's the bit that I'm interested in, because that's going to affect ultimately how we produce, how we work. And it is literally, I mean, Ollie, I don't know how to put it in a more direct way. You can almost take a line and say what's happened up to now with computer development in terms of CAD design, etc. You can slate that away and say we're going to start with a new page, like literally a black and white, right? And and a lot of people are saying to me, "Oh, but this and what does." And I speak to a lot of people from different industries, and I said, "Well, don't stop with doing what you're doing now." I just had a long interview with someone doing industrial design, and asking questions about what I should do in the future. Don't stop what you're doing now, but please, whatever you do, get familiar with the tools of the future, because the tools you're using now, they're on a time limit.
Yeah.
Period. They are on a time limit. That's the end of it. So it's most of them, at least. So the AI enablement, and this is the great thing. I talk about the enablement. It's not going to be a necessarily like Photoshop has done a great example of that. It's not going to be necessarily, hey, Photoshop doesn't exist anymore, we have something new. No, we still want Photoshop in a way, but like you said, 5 seconds versus 3 hours, right? And anyone can do it because anyone can type, right? That's the
exactly. Yeah.
Make me a logo, right? I mean, give me 50 logos.
Yeah.
I'll take logo 3, 4, and 5 and make it into the same logo. I mean, and I'm talking to it like I'm talking to you. Yeah,
so what would your thoughts be for a young architect just started architecture right now? I feel it's a pivotal moment.
Can't ask me that.
What would you? Yeah.
I would say go become an electrician or a hairdresser. That's what I'd say. Seriously. No, I'm joking. We definitely need great architects. So it'll be a thing. I mean, I got given a lot of flack years ago when people told me all architects should learn to code, and I said no, they should learn to design. Coding is something you can learn. Design is something harder. So first and foremost, I mean, besides getting familiar with what's going on in the world and picking a couple of the tools and understanding the human interface to compute, right? How you want to interface with a computer. If you are a sketching type of architect, or you're more of a, not a great sketcher, but you're doing something else, understand the tools that are being developed. Don't lock onto them because they are very fluent at the moment, and some may come and some may go. But understand all the tools that can help you automate rudimentary tasks. Tools that can automate drawing production, tools that can automate 3D model generation, tools that can automate sketch to 3D for conceptualizing, tools that can automate the environmental analysis, various levels of environmental analysis that you need to do, but don't have the skills to, and don't need to be a specialist in, right? Because you don't want to be studying 6 months or a year to understand exactly what it is to do environmental analysis. When you're doing a sketch, you want to understand what the effect of the sun's going to be on the adjacent plane or park or something like that. So get familiar with that, but more importantly, understand to be a designer and understand what humans need. Right? We can build all the crap we want, but if it doesn't answer what we need as a world, right? As inhabitants of the earth, and I'm saying this a bit philosophical in a way, we're going to carry on producing crap. Right? Understand where we can make the changes, and don't be scared to think different in terms of the adoption of new ways of building and inhabiting people. Because if you look at it in its core, right, we humans, we need to be protected and sheltered and fed. Right? That's the basics we need. We don't need to be glorified. We're really not that important, but we want to do it in a way that's sustainable. So understand these things, and again, I get back to the human. I'm getting a little philosophical. I need to tone down. I'm more a technology person, but we need to get back to the human aspect of things, right? I mean, what is it that we actually need, and how are we going to deliver that? The how bit is the feature of the tools that we will have, and include
like learning to design and learning the human side, but don't ignore what's going on. Like jump
absolutely
into it, adopt it, test it, play
absolutely
with
it. Not. Yeah. But don't, as a few years ago, focus your studies on being a software technician. Don't do that. No, because honestly, it is, let's look at a CV. Let's go down to the bottom in terms of software skills. Okay, let's see what this person done as a portfolio. But that's not the way. I think I don't believe it should be like that. And even the point of AI now, if you want to get involved in AI, you don't just get involved in AI, right? You do mathematics or computer science or application. You get involved in the subset because it's such a complex field. And it's the same with design in a way. You can't just be, find your niche where you can actually help the industry in what you want to do.
Yeah.
And work with that.
Yeah.
So.
Cool. Well, I would suggest everyone to go and check out all these things for sure. Check out a bit more about Omniverse because it's kind of like a
and we're very excited about that.
Exploding mind.
Yeah.
I know you guys do
scale. Especially in scale. Sorry. So there's a lot of concerns, and I understand a lot of the concerns that's raised for software developers and so forth. But the real underlying thing, it takes any form of collaboration out of the picture. You play in an agnostic field, right? And that's an important thing. So anybody can play with at any level of compute. And that's why the Open Alliance for USD has been developed. And you can keep an eye out on that because there's going to be a lot of sub-development that can get merged into the main branch of USD that will affect architecture, manufacturing, automation, all the actual things that we need to do to produce, right? And to construct and to kind of live. It's by no means a visualization platform, by no means anymore a schema. So
no.
It's gone beyond that
for sure. So, it's a big.
Keep an eye what some of our software, some of your software users are doing. Keep an eye. Some of the really popular ones. I don't want to call too many names there, but even the ones you don't expect.
I saw you guys are often posting really cool stuff. Like today this week there was something about image to 3D modeling.
Neural Angelo,
cool. I think you guys do something with your eyes on a podcast, so you always look at the camera.
Yeah, that's a bit of a creepy thing that I'm not using that. I could enable it now, but I'm not going to do it. No, I want to make sure people know. I want to make sure people know that when I look at them and when I ignore them, right?
Yeah. But I get it. I get a lot of complaints because I look at the screen where you are, but like the camera's here. So
it's a cool tool, but it's a bit.
I feel like at some point my eyes would they look
a bit like popping out. No, it's a bit mad, but we are super excited. We're pushing. The great thing is as well is inside of NVIDIA we are applied. Our team are applied in different aspects. We're looking at really hardcore real life problems, and you talk about digital twins and the likes of these things. How to actually integrate and simulate and resimulate and optimize and apply and simulate and optimize and apply. And all those things we are learning, will be applied into the AEC field. And this is again the greatness about it, because I don't see AEC. I've never seen AEC as a bubble. Right? I always see it as an industry but there's other industries, and maybe because of my background. So how do they do this in that factory? Could we not do it in this factory? How do they design at scale there? If you look at some of the brainstorming ideas and so forth, why aren't we applying some of the methods that the really great industrial designers are using to solve products into building scale things? And it's all this kind of a way of thinking, but also an adoption of technologies, and we're doing it. I mean, we're involved with game engines, we're involved with AI already, but we're still going to go back to our little drawing board and make sure that that's what we do, right? I mean, don't touch my drawing board, whatever that platform might be or the software might be. So, and I think this is the excitement, and this is kind of why I stepped, because I kind of saw USD as this. We talk about functions. It's sitting up there, and we can just call functions whatever it is we want. If we want to call Rhino or Revit or a web app or an AI framework, they can all play together. Right? I can compute AI on a Blender model combined with Revit and Rhino, and I don't care less where they come from because it's one space.
Yeah. So for sure, my biggest frustration with NVIDIA is not investing a couple of years ago when I was thinking about it. Because
watch your space, right? We are really
not I should probably add a disclaimer. This is not advice to buy any kind of stock or any kind of financial advice. But
no, I mean, this is not an overnight decision. I think NVIDIA done. It's really a long-term, systematic, and progressive approach of understanding, developing, supplying, growing, understanding, developing, supplying, growing. And even with a new compute like Hopper and so forth that we're bringing out, it is really insane what the engineers come up with to answer the demand and questions. And we are a graphic company. We produce graphics cards, but the GPU is not a GPU anymore. The graphics processor is way advanced if you look at the RTX architecture.
I think there was some great talks by the CEO of NVIDIA about this was not. They just came up with this a couple of years ago already. This has been a long-term thing.
Yeah. It's hard,
so it's quite amazing.
Keeping the focus and keeping the momentum, but we're pushing it. So the keynote at SIGGRAPH is actually a really good thing to watch, even if you just watch the progression of technology from sort of the early 30s all the way up to where we are now. I played, my son's on holiday, I played Doom with him now, the latest Doom, and we're running it on RTX, and it's amazing because you see reflections.
Yeah.
But inside the game, you can go into a monitor and log into the first Doom that came out, right? And it's like chalk and cheese, right? I mean, you can't compare the two. You cannot compare the two. The ones running with full reflections and
the
pixely. No, not quite. But the pixely ones, and it's like that was 20 years ago in lifetime of humans. It's not a lot. And look what we're doing now. We're running really, real-time reflections with 60 frames a second or plus whatever. It's mad. It's mad.
It is mad. So our typical closing question, which I don't know if it's. Probably the answer is what you're doing, but what tech stuff do you see going on right now in the AEC industry that excites you the most? Maybe outside of NVIDIA stuff, but is there anything else that's exciting you right now that's maybe being missed a little bit?
No, I mean, look, the AI side of things I think is really cool. It's a really great way to create mood boards, and I'm really excited to see some of the people adopting that into their daily applications, right? The stable diffusions to take massing models into things, because it really takes out the production side of it. But in terms of AEC, I don't actually know if there's something that really excites me inside of it. I mean, definitely the generation of simulation models at scale, and we're talking scale, right? Just to clarify that, we're talking about buildings that are, a couple 100 meters, if not more, in size, and being able to look and understand and make decisions. And this is not something you could do in the past. It's not. And bring things at production level into these, or operation level, or human interface level. We've done some. I mean, I can't even tell you. It's above the 100 of files from Revit, etc., to open up into a single file for people to experience. So this democratization and this ambient function that's being put out there is probably the biggest one. But some of the software companies, I can tell you, well, I can't tell you what they do, but they are working on some pretty cool things. The ones that are that you use every day, and I'm very excited for how they are taking on technologies and systems and processes and making it part of their tool integration, kind of like what Photoshop has done and the likes. We see SpaceMaker AI moving into certain things, platforms now, and the others are doing similar processes to that. But
exciting times.
But there's some cool architecture coming out as well. Some really cool architecture, and some of these firms that are adopting some progressive stuff. So, but I can't tell you. I mean, I'm excited about a lot of things. Whether it's ASC locked, it's probably not. So,
yeah.
So,
no, that's awesome. I think this is a good point to end the podcast, because it's just touching on the future. We've touched on a lot of things. But yeah, I'm excited to hopefully have you in our Pecha Kucha coming up soon.
It'll be cool.
We haven't announced it yet, but it should be at the end of September.
That's awesome.
But yeah, where we can have you and a few other people. We'll be talking about the metaverse, game engines, and beyond. It's another one. It's hard to name, but just simply the metaverse and beyond. Like we're going into
this metaverse ... Like it's it's a little. Well, what didn't that happen last year?
Exactly.
Yeah, that's last year. Well, it's great. It's amazing, and yeah, Ali, again, thank you for this. I mean, I know we touched a lot of things, and on and off track, but it's always good to talk about the future.
Yeah, I'll put some links below the video of your LinkedIn and stuff if people want to reach out to you and find out more or question you. I guess LinkedIn's the best route, right?
Yeah. That's my business social platform.
The business.
You're not going to connect me on Strava. Let's put it like that.
Yeah. Cool. Well, thank you thanks again for coming.
No.
We'll be back in a month or so. I think we're going to jump onto some more AI guests. So we've got a couple lined up, but I can't release them yet. But we'll be back soon with another podcast. But Cobus, thank you again, and we'll see you guys soon.
Thank you very much, Ali.
Cheers.